Assalamualaikum and very good day. Today I will present my paper titled Strain Measurement for Composite Materials during Mechanical Testing based on FPG Monitoring. I am Maziat binti Muhammad from University Technology Petronas, UTP. Nowadays, the composite wraps has been used widely as the permanent repairing technique for leaking pipelines in oil and gas industry. It is because these materials are less complicated and easy to apply, as well as lighter and lower cost for the transportation and the installation. So as the composite wraps here can be considered as a permanent solution for repairing, it is necessary to monitor the composite wrap health and condition. And that's why our main objective for this project is to distinguish the FBG signals to various damage mechanisms of composite wraps, such as the crack of fibers, the delamination, and also the disbondment. Okay, this is some introduction of the FBG. FBG or fiber Bragg grating is actually an NDT multi-sensing that can detect and measure the strain, temperature, pressure, acceleration, and also the displacement. So based off its physical change on the specimen, so FBG can measure all the parameters because of the shifting of the reflected Bragg wavelet spectrum. So usually in application of this FBG, we will need the light, the broadband light, whereas the broadband light will illuminate the FBG sensor here. So as the light is hitting the FBG here, so we will have the reflected wavelength, and this reflected wavelength will play a significant role in strain sensing by undergoing left and right shifting as the optical fiber experience the tension and also the compression strain. And as the other unreflected light will pass through over the Bragg grating and will call as the transmitted spectrum here. So this is how the FBG sensor looks like in the real application. So this is the lab type of the FBG that we use in the lab testing. This is the materials and specimens we use for this project. So to replicate the composite wrap, we use the fiberglass sheet and mixing of epoxy resin and hardener and cut into this shape of a specimen. And to replicate the piping line or the parent materials, we use SS304 plate here. So because we want to see the difference between the crack, delamination, and disbondment damage mechanism of this composite, we have to run several tests using tensile test and also the flexural test. So the tensile test here is used to monitor the crack damage mechanism of the specimen, while the flexural test we use to determine the delamination and also the disbondment damage mechanism of the specimen. So for delamination and disbondment specimen, we introduce the Teflon layer in between the layers and in between the composite and the stainless steel plate here. So between the layers is to introduce the delamination damage mechanism, and between the composite and stainless steel plate here is to introduce the disbondment damage mechanism. And from the photo here, the green one is the location of the FBG that we glued on the specimen. So as we know, the FBG is based on the strain measurement. It is a localized sensor. So that's why we have to identify the right location to put the sensor so that all the signals gathered is monitored, the actual signals coming from the activity during the testing. So that is why we put the FBG here as per location stated in the table. This is the results that we collect from the testing. So this figure shows the trend for the strain response and the flexural test response. So it can be clearly seen that the increment and the decrement of the stress experienced by the specimens is clearly showing the same trend of the strain increment from the FPG response here. So for the crack damage mechanism, we can detect very high strain value that is range between 5,800 up to 9,000 microstrain here. And for the lamination, we can see the range is between 2800 to 4,000 microstrain. And for the disbonding damage mechanism, the strain range is between 1,200 up to 5,500 microstrain. So we can see the delamination and the disbonding damage mechanism. We can see that the value of the strain is some of it is overlapping to each other, the value of the microstrain. As the conclusion, we think that the FBG sensor has a great potential in detecting and distinguishing the type of failure mechanism of the composite materials, because from the results we can see that it clearly can detect the crack, the fiber crack with a very high strain value, and below than the value, we can say that the composite is now having the delamination and the disbondment damage mechanism. So it is good to explore the FPG technology to be installed as the monitoring system in the related industry in order to make sure that the composite wrap repairs is still in the good condition or not. All from me. Thank you so much for listening. If you have any question, please do not hesitate to contact me using this email. And I would like to thank the team member of this project and also the team member from Petronas Group, GTS and PDNT for their grant funded this research. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.